So I'm going to reveal the graph that you should have drawn. Don't mark it right or wrong right away. First, look, and then I'm going to point out a couple of things on the graph that you need to look at to determine whether or not yours is correct or incorrect. So, here's what the graph should look like. Don't mark it right or wrong yet, just look. Now I'm going to point out a couple of things. To determine if yours is correct, we look for two spots. You look for where it crosses the x-axis. It should be crossing the x-axis at -5. So look at your graph and see if it's crossing at -5. Now, if your graph, the line doesn't go all the way, now pick up your ruler and draw the line so it goes all the way. And then see if it crosses at -5. And then it should cross the y-axis at 1. If both of those things are true, then you can mark yours correct. If it's not true, then unfortunately it is incorrect. First of all, let's address the issue of why it's a line. And I should have arrows on either end, so let me add that in. Why is it a line and not just a set of points? Well, if it was just a set of points, then it would say domain, and it would give you specific points to use, but it doesn't do that. Or it could be a real-world scenario in which these points in between do not exist, and so that would also be discrete. But because there was nothing here, then we assume that it's all real numbers. And since it's all real numbers, we connect everything and draw a line all the way through. Because all of these points in between are solutions to that equation. So that's the first issue. Now let's talk about how I accomplished this and how you should have approached this. Here is the table of values that I used. And I specifically want you to look right here. Now, if you used a different set of inputs, you still should have gotten the same graph. The inputs doesn't really matter. As long as you get the correct output to match it, then you should be fine. But my table of values is much friendlier than others. For example, if you did this table of values, then unfortunately you were too robotic with what you did. Because you basically said, oh, Mr. Gallet said I must use -1, 0, 1, and 2, and that's what you do. But that's actually not what I said. I said that that works frequently. But you actually have to be thoughtful about things. And so if you did that, you can still get the same graph, but it becomes very uncomfortable. For example, if you plug in a -1 to here, then you get -1/5, and so you get 4/5 as your output. How are you going to graph 4/5? Well, this is it right here. But that's hard to estimate. And since the graph is not set up to put perfect fifths, that's difficult. So we want to avoid this because it's difficult to graph, not because it's a fraction. Fractions are no big deal. But because it's difficult to graph, we want to avoid that. So let's back up. Why did I choose -5, 0, 5, and 10? Why? Amir? The denominator of this fraction right here is 5. And so to counteract that, to balance it out so that I get nice, friendly outputs, we use multiples of 5 as our inputs, which will work out very nicely. I saw some of you did do that, and that was wonderful. If you didn't, you need to start concentrating on what is actually happening. and not being a robotic student and just following a procedure, you need to be thoughtful, okay? This is also not the first time you've seen something like this, so I expect you to be getting better and being more thoughtful. Are there any questions or comments about today's warm-up? This is going to lead us right into today. Any questions? All right, draw a line across your paper to indicate that we have finished the warm-up and that we are moving to the next section that we call today notes. And remember that you are a mature young person taking a high school honors class. And so I'm not going to tell you what to write down. I will guide you a little bit by highlighting things or underlining and circling things. And you're going to have to decide what to write down. But if you say to yourself, well, then I'm just going to write nothing, well, that would mean you're brilliant. If you can write down nothing and be successful, you are brilliant, and I want to know because then I want to move you into my geometry honors class. If that's not you, then you're just a above average human, but then you need to write some things down. So, today we're going to talk about two ideas. One of them you already know. We're going to talk about the idea of a function. And we know that a function means that every x value is only matched with one y value. And it could take a lot of different forms graphically. Here's one example. But in this case, and here's where today's a little bit different, we notice that this formed a perfectly straight line. And that means that this is a function of a particular type. It's called a linear function. And yes, you need to be able to say the word linear. And linear sounds like a big boy word, but it's actually very simple because the first four letters spell the word line. So a linear function means a function that will form a line. So, function, linear function. This is just an example. So, you may have questions already, but I want you to hold off because we haven't even really done anything. So what we're going to do today is we're going to learn how to identify linear functions and equations. How to look at them and know whether or not it's linear. By the end of today, you should have a good idea how to tell. We're going to look at it from three different perspectives. First perspective is we're going to look at graphs. For this example, I don't want you to copy down the graph. I want you to participate, involve yourself, and try to understand what we're talking about. And I'll be honest with you, compared to some of the other work we're going to do, this is the easy part. So first, we want to be able to identify a linear function by looking at its graph and saying whether it's linear. Okay? So, the instructions. Identify whether the graph represents a function. So that's really one question. Is it a function? And then the second question is, if it's a function, is it a linear function? So we have two things we want to be able to say. Yes, it's a function, or no, it's not. Yes, it's linear, or no, it's not. So, first, the idea of a function. I introduced to you a simple test you can do to determine if something's a function by its graph. It's called the vertical line test. You can use your pencil or ruler as your vertical line, and it needs to be perfectly vertical. So I've used the computer's power to draw a perfect vertical line. If you drag the vertical line across the graph, if it always touches one point at a time, always, then that's called a function. If at any point it touches more than one point, then that's a broken machine and it's not a function. And just to be clear, when I say the graph, I'm talking about this line. I'm not talking about these. That's the grid. This is the graph. So watch. drag it across, it always touches one point. Touching one point right there, touching one point right there, touching one point right there. No matter where I move it, it's always touching one point. Let's look at part B, and we'll come back to part A in a moment. Is it always touching one point? Yeah, it's touching one point there, touching one point, touching one point. No matter where I put it, it's always touching one point. Let's look at part C and compare it. What if I drag it across part C? Is it always touching one point? Well, it's not touching at all, it's not touching at all, now it's touching a whole bunch of points. It's touching all of the points, in fact. So that's not a function. Because for it to be a function, it can only cross one point at a time. So the vertical line test is a very simple way to say, oh, not a function. Okay? So let's go back up here. So we've already figured out that this is a function. Oops, excuse me. This is a function. And now we need to look at it. And we need to say whether it's linear or not. And remember the first 4 letters of the word. Does it form a perfectly straight line? So part A, give me a thumbs up if you think this is linear. Lots of people think it is. Yeah, it's linear. So we call this a linear function. You can write function linear, linear function. I don't really care. Any questions about that? Part B, we already did the vertical line test and we saw that it is a function. But now the question is it linear? So let me ask you again. Give me a thumbs up if you think it's linear. Nobody put their thumb up. Yeah, it's not a perfectly straight line. There are parts of it that look like they're straight, but a perfectly straight line means the whole thing is one perfect straight line. So this is not linear. So you could have a function that's linear. You could have a function that's not linear. Let's see what happens here. We used the vertical line test and we figured out that it's not a function. Now, technically, if it's not a function, you're just supposed to stop. But let's just go further anyway, and let's look. Is that linear? Give me a thumbs up if you think it's linear. Some people think it is. Some people think it's not. Okay? So what I'm asking is, does it form a perfectly straight line? And you're saying it doesn't.
It does form
a perfectly straight line, but it's not a function. But we can still say it's linear. But technically speaking, if you read the instructions, it says, if the graph is a function, then is it linear? But we can still say it's linear. But technically, we're not supposed to go any further. Okay? So you could have something that's a linear function. You could have something that's a function and not linear. Or you could have something that's not a function. Anyone have any questions on what the possibilities are? All right, let's see how you do on your own. So it's the exact same instructions. You don't have to copy them. You need to, of course, write checkpoint number 1. You do not have to copy the graphs, but there are 3 of them, so I need to figure out how to squeeze in all 3, so give me a moment. Yeah, you can see all 3 of them. So that's A, B, and that's C down there. So you got, let's say, a minute and a half to figure out whether or not they are functions and whether or not they are linear. A minute and a half. All right, let's see how well we understood part A. You need to tell me whether it's a function or whether it's linear. So let's go with, look at your desk, your new desk, and make a note of what letter and what number you are. And I need number 4 and number 9. Number 4, what did you think?
It's a function and it's linear.
Okay, number 9. So you two agree. It is a function and it is linear. Part B, I got student number 15 and student number 16. Number 15 is not there. Number 16, what did you get? You think it's a function and that it's linear? It is a function that is linear. Very good. And part C, I've got student number 6 and student number 14. Student number 6.
I thought that it was not.
Okay, and number 14 is not there, so we got not a function. Very good. Anyone have any comments or questions? Cheyenne?
For A and B, it's also right if you put linear function.
Absolutely, that's probably even better, writing linear function.
Didn't you say it's like you make a line and then the points plus 2 points, it's not a function?
Yes, but it's a vertical line. It's called the vertical line test. Has to be a perfectly vertical line. It can't just be any line. It has to be a vertical line. That's why it's called the vertical line test. Write that down so you remember. Vertical line test. You can put vert line test too, but it's vertical line. Any comments, other comments, questions? Okay, so now we have one way to tell if something's linear, by looking at a picture of it. Now we're going to explore something related. Do not write anything down, just look and digest. You can also look at a table and tell whether it's linear or not. So let me hide this for a second. Should have had this hidden. So let me get rid of this for a second, and let's look at what's going on here. This is a table of ordered pairs, x comma y. You have experience with this. What you don't have experience with is looking at the pattern that happens as you go down the column. So look at what happens. -2 to -1, we go +1. -1 to 0, we go 1. +1, +1. So there's a pattern. It's the constant change. It's changing by adding 1. So now let's look at what happens to the y's when that happens. To go from 7 to 4, we subtract 3. To go from 4 to 1, we subtract 3. To go from 1 to -2, we subtract 3. To go from -2 to -5, we subtract 3. So when we have a constant pattern with the x's, if we have a constant pattern with the y's at the same time, then that's linear. And I can show you, you already saw it, so the cat's kind of out of the bag, but I can show you, this is the graph of that table. And it forms a perfectly straight line. But we now don't need the graph. We can look at that and say, oh, that's going to be linear because of the pattern. Also, you know, if I did give you this, you just spent time learning that this also says it's linear. So either way, we can tell that it's linear. Let's look at a table that turns out not linear. We have a constant pattern with the x's. We are adding 1 every time. Add 1 every time. But look what happens with the y's as the x's are increasing by 1. This one subtracts 3. This one subtracts 1 to go from here to here. This one adds 1, and that one adds 3. This is not a constant pattern, a constant change. So as this changes at the same rate, this does not. And this forms this picture, called a parabola. It looks like a U, and you've actually seen this before already. So that's not linear. So you should be able to look and say, oh, that's not linear because of that right there. Also, the change in the x's could be different. Look at the warm-up. Look at what the change was in the x's in the warm-up. +5, +5, +5. Doesn't matter as long as it's the same every time. +5, +5, +5. Look at the y's. +1, +1, +1. Linear. So we can show it a whole bunch of different ways. Any questions about that? So let's see how we can use this to analyze some situations. So, example 2. Tell whether the ordered pairs that I'm giving you becomes or will form a linear function. So, of course, write example 2. And you don't have to copy the instructions. And in fact, for part A, I don't want you to copy the set like it is. We're going to immediately change it to something else. We're going to change it into a form that will make more sense. We're going to turn it into a table so that we can analyze it. So make a simple t-table, which just means a simple 2-column table. And of course, the column on the left will be the x's, and the column on the right will be the y's. And instead of copying the set as it is, let's translate it into a table. 0, -3. 4, 0. 8, 3. 12, 6, and then 16, 9. And now let's analyze and see whether or not this is going to be linear. Let's look at the change on the left. What is happening as we move from one x value to the next? Yudesh? Chanel, do you agree? It's adding by 4 each time. So that's constant. So maybe this is linear, but that's not enough evidence to support it. So now I need to look to the y's and see if those are moving at a constant rate. Constant change. What's happening here? Marcus? Do you agree with that, Amani? It's adding by 3? Yeah, it's adding 3 each time. And so that evidence tells us that this is going to be linear, even without graphing it. Without even graphing it, you already know that this is going to be linear. Anyone have any questions about that? Well, think of it as training wheels, like I've referred to before. If you can get these questions right every single time and not have to draw anything, great. But if you get questions wrong, that's not okay. So it's basically based on your performance. Okay? If you can assure me that you're going to look at every single one of these and you're going to get it right every time, then go ahead. Let's see how you would do with this one. Part B. Again, I don't want you to copy it as it is. I want to immediately make a t-table and translate the ordered pairs into a table form. -4, 13, -2, 1, and so on. Yudesh, you think you've got it figured? So is it linear? You don't think so? Okay, let's see if he's right. So what's happening? What's happening here each time? Gary?
Adding 2.
Adding 2 each time. And what is happening here? David? Well, this is, if you added 12, this would be 20, subtracting 12, very good. And then this is subtracting 4, and now it turns to adding 4, very good, and then adding 12. And so this is not linear. Does anyone know what it will become? Kaylee? That's right. It will draw a parabola. You can actually tell because even though this isn't constant, there's actually a pattern here. See the negative 12 and the positive 12, negative 4 and positive 4? See how they're opposites? This will draw a parabola somewhere. So this is not linear. That's what we were asked. We were asked whether it was linear or not. It's not linear. Any questions about that? Any concerns? Okay. Checkpoint number 2. I'd like you to compare these two sets. Tell me something about them and about whether they're, linear or not. See what you can figure out. 2.5 minutes. All right, let's see what we came up with. Right or wrong, doesn't matter. Effort is most important. So let's go with student number 4, student number 2, student number 8, and student number 12. So number 4, what'd you put?
Not linear.
Okay. Number 2, what'd you put?
Is that 8? Yes.
There's one question here, so Matt, you just tell me what you put.
Like I put set A is not linear and set B is linear.
Okay. Student number 8, what'd you put? Okay, and student number 12, what'd you put?
Set A is not linear, set B is not linear, and set A I don't know where, but it's one C.
Okay. All right, so It wasn't, it's fine if you put two different answers. It's not really a big deal, but I wrote the question just differently because you're going to see it, you're going to see a question like this again. And when you asked to compare things, you need to analyze the first one, analyze the second one, and then compare them. And so you basically put it into one statement. Again, if you put it into two statements, I don't care. Set A is not linear, set B is linear, and then you went further, Amir, and you said that set A forms a parabola. Is that true? Let me see. There's 1, 2, 3. I'm not sure if it does, but I'll check it. Okay? I'm not sure. All right? So now, I'm going to rewind for a second to show you what we've done, where we've been, and where we're going. We can now look at a graph and tell whether something's linear. Linear, not linear. We can now look at a table and tell whether something is linear or not. Linear, not linear. So we have two ways to tell. There's a third way to tell, and this is really important. This is actually going to lead us to a whole bunch of other ideas. And it is by looking at the equation itself. Another way to look is to look at the equation, and if an equation can be rewritten to look like this, then you can also say that it's linear. That form is called standard form. That word form is important because it's just one way of writing the same thing. So a linear equation or a linear function could be written in standard form. Another way to say it is the other direction. If you look at an equation and it's in standard form, then you know it's linear. Now, first of all, this has to be committed to memory. Whether that means you memorize it by using flashcards or you just get to know it because you use it so often, doesn't matter. But it must be stuck in your brain forever. And now I want to clarify a couple things about it. This says ax plus by equals c. A, b, and c are numbers. Those are numbers. The x and the y stay. Those numbers could be positive numbers or negative numbers. Doesn't matter. They just have to be numbers. Last thing. Since there's no exponent written here or here, there is an exponent though. What is the exponent if there is none written? Money? It's 1. So if there's no exponent, then that means there's a 1. So when you say standard form, you're talking about x to the first power and y to the first power. If you see this, that is not standard form. If you see this, that's not standard form, and that's not linear. If you see a 3, that's not linear either. So it's only linear if both of these are 1s, also if they're not there at all. Okay? Any questions about that? So that's one thing, and I kind of wrote it out here. For it to be linear, both exponents need to be 1. X and y cannot be multiplied together, and x and y do not appear in the denominators, in the exponent, or in the radical sign. So, here are some examples and non-examples of linear. This is linear because it's in standard form. This is linear because we could rewrite it in standard form. So this is the same thing as this. This is also linear because it can be rewritten in standard form. So that is the same thing as that. These are not linear. X and y cannot be multiplied together. That produces something different. So that's not linear. This x is raised to the third power. That's not linear. and this has a y in the denominator, that's not linear. That will graph something different. So you have to be able to visually look and tell if something's linear. Any questions about that? Okay, so I'm trying to improve myself, and so I did this lesson with 2 other classes, and I've learned something, because a lot of my students are missing a skill or missing an understanding of something that's making it difficult to get to the next idea. So this was what we were going to do next, but I'm going to put in a little intermediate, little quick thing that I want to do. So I'm going to pick an equation. Let's see, let's do 4x minus 5y equals 8. So here's something that you were supposed to already have learned, but I've noticed a lot of my students don't know. We are allowed to rewrite this equation any way we want, as long as you follow the rules. For example, if I just walked in the room and I was feeling wacky and crazy and I said that I don't want the 8 there, I want it to go to the other side. Well, there's rules for what you can do, but I want the 8 to jump to the other side. How do I do it? So let me just be clear that everyone in the room should know how to do this. If you don't, make sure you're paying extra close attention. How do we get the 8 to jump to the other side? Adriana? Oh, okay, so thank you. We could just flip it around using the symmetric property. You're absolutely right. But I want everything else to stay on that side. So I want the 4x to be on the left, the negative 5y to be on the left, and I want the 8 to go to the left. How do I do it? You can't? Okay. She thinks we can. Alex? Subtract 8 from both sides. Let's see if that will work. That cancels out. I get 4x minus 5y minus 8 equals 0. Did it jump to the other side? Yeah. Not only that, it jumped to the other side. And what happened to its sign? It flipped, right? It went from positive to negative. So I'm allowed to do that. Now, did that get me anything? I don't know. Did that help me in any way? I don't know. But I'm allowed to do it. Okay? Let me back up, and let me move this over, and I'm going to start with the same exact one. 4x minus 5y equals 8. I walk in the room and I'm just feeling wacky crazy. I want that negative 5y, I want that to jump to the other side. How do I make it happen? How do I make the negative 5y jump to the other side? Chanel? Add 5y to both sides. Let's see if that will work. Add 5y, add 5y. That cancels out, and I get 4x equals 5y plus 8. Did it work? Yeah, it jumped to the other side. Now, did it help me? I don't know. It doesn't matter. The point is am I allowed to do it? Yes. You are allowed to add 5y to both sides. You are allowed to subtract 8 from both sides. Okay? Let's do another one. Let's do 4x minus 5y equals 8. But now I'm feeling not only wacky, but I'm feeling like a challenge, and I don't want that 4 there anymore. I want that 4 to turn into a 1. How do I make that happen? I want the 4 to turn into a 1. Michael. Divide both sides by 4. But now watch what you were taught. Divide both sides by 4. Divide everything by 4. That's what you were taught. Let's see if that works. That cancels out, and we're left with x. Negative 5 divided by 4, well, can't really simplify that too much, so let's just put negative 5/4 y equals 8 divided by 4 is 2. Am I allowed to do it? As long as I do it correctly and I follow the rules, you're allowed to do it. The question is, does it help me? I don't know. But I'm allowed to do it. So now, what is Mr. Gal talking about? I'm talking about that you are allowed to rewrite an equation a million different ways, and it's still the same equation. Guess what? This is the same as this, is the same as this, and is the same as this. Do you remember the conversation we had about money and I asked you to give me different ways of making a dollar? Can someone raise their hand and give me a way to construct a dollar? What's one way to construct a dollar, Cheyenne? 4 quarters. That's one way, but it still has a value of a dollar, right? Give me another way. Marcus? 10 dimes. That's 10 dimes, but it still has a value of $1. David? 100 pennies. 100 pennies still has a value of a dollar. But here's the thing. Which is the most convenient to carry around out of those 3 choices? The 4 quarters, the 10 dimes, or the 100 pennies? Which is the most convenient in your opinion, Yasmin? The 4 quarters? Why? It's less what? Because is the value less? Okay, but it's the less, what's less? The amount of what? For what? Coins. That was the magic word. That's 4 coins versus 10 coins versus 100 coins. But they all have the same value. So having it in a form helps you. Having 4 quarters helps you. If you want to go to the vending machine during passing time, having 100 pennies doesn't help. Because you can't put pennies in the vending machine, can you? You can put quarters in. So having the quarters helps you. So is that as interesting as equations? No, equations is not interesting. I understand that for most of you, but the point is the same. That you could have this form, this form, this form, or this form. And you're going to find out starting today and moving forward that one of these forms gets us something. One of these forms is more convenient, more efficient. Are you allowed to have the other forms? Yes. Could you convert 100 pennies to another form? Yeah, if you go to the bank, you could convert it. But it all depends on what you need it for. So now, standard form. Standard form is one special form of an equation, and it gets us something. I didn't tell you what it gets us yet, but it gets us something. Well, actually, I did tell you. It tells you that it's linear. So that's one thing it gets us. So now let's see what we can do with it. Okay? So, example 3a. So there's 2 parts to example 3. Graphing a linear function. You already know how to do this. But we're going to do something first. Tell whether the function is linear. Well, if it's linear, it should be able to be rewritten in standard form, which I have over here on my whiteboard so you can still see it, although you have it written down on your paper. So if we can rewrite that into this form, then we know instantly that it's linear. But I would go a step further. I would expect you to be able to look at it right now and tell me whether it's linear. Maybe you could, maybe you couldn't. Well, let's see if we can rewrite it in standard form. For it to be in standard form, the x needs to be on the left, the y needs to be on the left, and then any number needs to be on the right. So let's analyze this. Is the x on the left already? Yeah, so the x needs to stay there. What about the y? Is it on the left already? No, so how do we get it to jump? Isabella, what do you think? How do we get it to jump from the right to the left? Beautiful. Subtract 2y from both sides, and it will jump. This will disappear, and now we get x minus 2y equals 4. Well, now does it look like, and I should get rid of this, is it in standard form now? Yeah, it is. Even though there's a subtraction sign there, that's the same thing. ax plus by equals c. What is a equal to? What is a equal to? Jesse? 1. Very good. What is b equal to? What is b equal to? Laurel? b is not equal to 1. No. I'm sorry if I'm confusing you and putting you on the spot. We are looking right here. I'm asking you, what is b in that case? It's not 2, and you're going to kick yourself when you hear it. What is it, Alex? It's negative 2. And what is c in this case? What is c? Tristan? 4. So these numbers have special meaning that we're going to get to soon. So putting it in this form gets us something. First of all, it told us that it's linear. So we can now say that this is linear. And it gets us these pieces of information that we can use for something in the future. Does anyone have any questions about that? Now, we're supposed to graph this, and you're going to graph for homework, but I have limited time, so I'm going to focus on converting to standard form and telling whether or not something's linear. So we're going to skip this, even though we're not supposed to. Okay? And let's go to part B. Tell whether this function is linear. If so, graph the function. So take a look at it, and I want you to tell me, I want you to lock into your head whether or not it's linear. So you're saying linear or not linear. Linear or not linear, lock that in your brain. Like a neon sign flashing. Linear or not linear. Give me a thumbs up if your neon sign is linear. Okay, good. 1, 2, 3, 4, 5. Good, put your thumbs down. So many more of you said it was not linear. You said it was not linear. Kaylee, you said it was not linear. Why?
Because you can't multiply the x and y.
That's exactly right. That was an absolutely beautiful explanation. If x and y are multiplied by each other, that's not linear. X has to be added to y. This would be linear. This would not. Let me show you a different way. Can we rewrite it so that it's ax plus by equals c? Well, let's try. Let's try. Divide x on both sides. Y equals 4 over x. No, that didn't work. Let's back up and try getting rid of the y. Maybe that will help. Let's get rid of the y. Divide both sides by y. Divide by y, divide by y. That cancels out. I get x equals 4 over what? Well, no, that didn't work either. There is no way to turn it into standard form, which means that it is not linear. Not linear. Any comments or questions about that? Tristan, yes. How do you graph it? You're not going to learn how to graph this until you get to Algebra 2. If I have a moment, I'll try to show you what it looks like. I can do it using a computer program. Okay? So, if it's not linear, then you don't have to graph. For your homework, if it is linear, you do have to draw the graph. Okay? How do you draw a graph? Well, you already know how to draw a graph. You do this. That's how you draw a graph. So that's why I'm not worried about going over that. You already know how to do it. Okay? Any questions about that? All right, so there is a checkpoint. I'm going to skip over it for now. It's okay. And I want you to draw a line across your paper, which tells us that we're done with the lesson and now we're moving to the homework. And on page 81 in your workbook, you're doing numbers 1 through 5, and on page 182, you're doing 1 through 6. And I'm changing, instead of calling this total questions, I'm calling it points, because I'm going to start giving a certain number of points to certain questions. But for tonight, everything's 1 point. Okay? You will have a quiz soon, but I don't know when. The schedule's a little bit messed up, and I just don't know when it will be. Okay?